Is this a cable? Well, of course it is.
No, it's not.
Hey? Every electrician who sees this is going to think it's a cable. And then they might think, well, what's the current carrying capacity of that cable? And I get it. That's the right question to ask for a cable. But here's the problem. This isn't a cable. It's better to think of it as a system. And that distinction, that single shift in how you view this system is going to change how you spec installations like hotels, commercial builds, and pretty much anything where you're going to be running multiple power points down a single corridor or run. Now, it does make the point harder to make when the manufacturer calls it a cable. Thanks for that. Anyway, by the end of this, you won't just understand why the Wieland system PODIS works, you'll understand why the way most electricians think about it is the very thing stopping them from using it. And that current carrying question, we are going to answer that, but the answer is going to surprise you. Okay, let's build a picture. A hotel, 4 floors, 10 rooms per floor. Okay, let's zero in on a floor. You've got a distribution board on each floor, or a riser feeding each floor from a main panel. And from that board, you're running individual cables to every single room. Each cable is sized independently. Each one has its own MCB. Each one is pulling from that board. Now let's add in the containment. Trunk in, the full length of the corridor, conduit drops into each room. We're talking 10 outgoing ways before you've even thought about communal areas, lifts, or back of house. But what if you could do all of that full power, future-proof capacity with one cable run? Not as a compromise, as an upgrade. Before I go any further, I know what some of you are thinking. That's just how it's always been done and it works. And you're right, it does work. Nobody's saying that the conventional method is wrong, but it works and it's the best option aren't the same thing. They haven't been for a while now. Right, let's reframe this. If you've installed busbar trunking in a commercial or industrial building, a factory, a warehouse, a data center, you already understand the principle behind the PODIS. You just might not know it yet. Busbar trunking is a backbone. One system running the length of the building. Tap-offs clicking in wherever a load needs feeding. The backbone carries the aggregate current. Each tap-off draws what it needs. The PODIS is that principle. A bus bar which runs the length that you need. Tap-off boxes clipping into each room doorway. There is no separate containment, no individual cable route, no 40-way board. But there's another important distinction here that often gets overlooked. With a conventional installation, you're not just installing a cable. You're effectively creating your own distribution system. You choose the cable, you choose the junction boxes, you choose the glands, you choose the termination methods, you choose how the cable is supported. Every one of those decisions is made by the designer or the installer. PODIS takes a different approach. Instead of selecting individual components from different manufacturers and bringing them together on site, you're installing a complete engineered system. The cable, the tap-off units, the end terminations, the connectors, the supports, and the accessories have all been designed and tested to work together. That means you're not deciding which junction box is best or which gland you're going to fit for every connection point. Those engineering decisions have already been made as part of the system design. Now, for some electricians, that might sound like you're giving up a little flexibility, and to some extent you are. But what you gain is consistency. Every connection is made the same way. Every tap-off uses the same proven connection technology. Every component has been designed to interface with every other component. Rather than assembling a collection of individual products on site, you're installing a complete electrical distribution system that's been engineered, tested, and validated as a whole. And that's reflected in the product standards too. Depending on the component you're looking at, you'll see compliance with recognized standards such as BSEN 61535 for installation couplers intended for permanent connections in fixed electrical installations, alongside the relevant standards that apply to the cable assemblies and associated system components. Okay, let's stop and sit with that for a second. One cable run, one supply feed, 10 rooms tapped off along its length. The system is the cable. The cable is the system. Now here's where it gets technically interesting, and this is the bit that answers the current carrying capacity question properly, because the current carrying capacity of a PODIS system doesn't work the same way as the current carrying capacity of a point-to-point circuit. And once you understand why, the whole system makes sense in a way it didn't before. Let's start with what we know. In a conventional install, a cable carries its full rated current from one end to the other, from the MCB in the distribution board all the way to the final circuit it's feeding. So hotel room 1, 32 amps, 6mm singles in conduit, clip direct. That cable is sized to carry 32 amps over its entire length. It doesn't matter whether you're at meter 1 or meter 45, the full current flows through the whole cable. Same for room 2, same for room 3, all the way to room 10. Each single cable on that floor is designed to carry its maximum load over its full length. That's conventional thinking, and it's absolutely correct for that model. But here's the consequence. 10 separate cables, each carrying their full load. 10 individual protection devices, a board sized to handle the load of all 10 circuits at full demand. Now, what's the maximum theoretical demand? 10 rooms at 32 amps each, that's 320 amps of connected load. That's your incoming supply cable sizing conversation. That's your main switchgear. That's a very large number, and that's only on one floor. But here's the thing about that 320 figure. It's theoretical. It's a worst case that will almost certainly never happen, and later we're going to talk about why. But first, the PODIS model, because it is a bit different. In the PODIS system, there is one cable feeding all 10 rooms, and this cable, unlike a conventional point-to-point run, doesn't carry the same current along its entire length. Think of it like this. Section 1 of the cable between the supply feed and the first tap-off has the potential load of all 10 rooms. Everything downstream of that point draws through that first section. At tap-off 1, room 1 takes its load. Now that remaining section of cable only needs to carry the load of the 9 remaining rooms. At tap-off 2, room 2 takes its load. The next section carries 8 rooms worth of current, and so on all the way to the end of the run. The very last section between tap 9 and tap 10 is only carrying the load for one room, which raises an interesting question about cable design. Unlike a conventional cable, a PODIS is doing less work as it progresses along the corridor, not the same work. That's a fundamentally different way of thinking about current, and it's why you cannot evaluate a PODIS system the same way you would evaluate a conventional circuit cable. Now, back to that 320 amp theoretical maximum. In a hotel, that number is fiction. Not because the loads aren't real, they are, but because they don't all happen at the same time. And that's what diversity is about. Take your 10 rooms. On a typical weeknight, what's actually on? Some rooms are empty, some guests are asleep, some have a TV on standby and a phone charger ticking over. A few might have a kettle going. Someone's running a hairdryer for 10 minutes. The installed connected load might be 320. The actual measured real-world demand at any given moment is a fraction of that. This is why diversity factors exist in electrical design, and in a hotel environment, properly applied diversity means your supply cable is nowhere near the theoretical maximum. You might be looking at 40, 50, 60% of that figure, depending on your occupancy profile and load characteristics. Apply that to our 10-room floors. 320 amps theoretical with 50% diversity, 160 amps actual demand. The supply cable, the main switchgear, the whole upstream infrastructure sized for reality, not worst case. And this applies equally to a conventional install, by the way. That's fair. Diversity isn't unique to PODIS, but what is unique to PODIS is what happens when you combine the diversity argument with the diminishing current principle, because now you're not just saving labour, you're running a leaner, better specified system throughout. There is one more piece of this that's worth calling out. Cable current ratings are based on continuous operation. That's the standard. A cable that's rated to carry 160 amps continuously means it can do that all day, every day, without exceeding its maximum operating temperature. Now ask yourself, in a hotel corridor on a PODIS, how often is that cable actually running at full rated current continuously? Almost never. Your peak demand window in a hotel is probably breakfast, say 7 to 9 in the morning. Kettles, hair dryers, everything going on at once. Maybe a couple of hours in the evening, that's it. Outside those windows, the cable is comfortably running within its rated capacity. In most hotel scenarios, the thermal load on the PODIS is well within its limits for the vast majority of its operating life. This matters for two reasons. One, it gives you confidence that the system is operating comfortably within its design parameters. Two, it reinforces the diversity argument. So, if the cable is running lean, the system costs less to install than conventional. So why isn't every hotel being wired this way? The answer, if we're being honest, comes down to familiarity and cost perception. And that's exactly what we're about to tackle. Let's put it side by side. Same hotel floor, 50 meters of corridors, conventional install, 10 individual cable runs, each one pulled from the board, each one terminated at both ends, each one protected individually. Your distribution board has 10 outgoing ways just for room circuits. Your containment is running the full corridor. The infrastructure spend is front loaded. The board, the containment, the labour. It's a big number before you've connected a single room. One PODIS cable running the length of the corridor, one supply feed from the floor DB, or directly from a riser. Tap-off boxes at each room doorway. No individual cable routes, no complex containment systems. The PODIS is the distribution. And here's the piece that doesn't get talked about enough. The same cable, the one feeding 10 rooms today, is the same cable that feeds those rooms plus EV charging in the car park tomorrow, or smart room controls the day after, or additional loads as the hotel upgrades. With conventional, every new load is a new cable run, a new MCB, a new route through the building. With PODIS, you're already there. But before we get to the numbers, because the numbers are significant, I want to address the objection I know is forming. Insulation piercing connections, long-term reliability. We covered this in detail in our car park install video, but it's worth mentioning one important point here. The PODIS tap-off units are junction boxes designed in accordance with IEC 60670-22, incorporating integrated insulation piercing clamping units designed to IEC 60998-2-3, which in the UK is adopted as BSEN 60998-2-3. So these aren't improvised field connections, they're engineered connection systems designed specifically for permanent electrical installation. But the short version is this: the connection technology is engineered for exactly this application. Sealed, gas-tight contact, no degradation pathway. It's not a workaround, it's the design solution. Right, let's talk numbers, because this is where it gets uncomfortable, as the PODIS system may not come out on top. We're going to look at some cost comparison data that was sent to me by Wieland, and already I know what you're thinking in your head. Well, of course they're going to say it's a better cost comparison for their system, and that's what I thought. So I did my own research as well, comparing PODIS against conventional point-to-point installation, labour rated at £70 an hour based on the Lukin's guide. And here's what the conventional quote doesn't show you. Yes, the PODIS materials cost more, around £6,000 against £1,700 for a conventional new build run. So on paper, you're £3.5 grand down before you've picked up a tool. And here's what the conventional quote also doesn't show you: the labour. Conventional, 208 hours on site. 208 hours at £70 an hour, that's £14,500 in labour alone, against PODIS, which clocks in at 33 hours. So the total installed cost: conventional new build, £16,287. Total installed cost of the PODIS, £8,342. That is nearly double the cost to do it the old way. And if you're retrofitting into an existing building, adding a new distribution board, chasing containment through finished ceilings, working around a live hotel, that conventional figure climbs to over £20,000 against the same 8.5 grand for the PODIS. But here's what I really want you to sit with, because this is the bit that doesn't show up in the materials quote. The conventional install took over 200 hours. That's 5 weeks of a single electrician's time. The PODIS install, 33 hours, under a week in a working hotel. And if this is an existing hotel rather than a new build, that's not just a saving for the electrical contractor, it's a saving for the hotel as well. Every day a floor is out of service is another day those rooms can't be sold. Finish the installation sooner, hand the rooms back sooner, and the hotel can get back to doing what it does best: welcoming guests and generating revenue. In a working hotel, that's the difference between a minor inconvenience and a major disruption. And it's the difference between a contract you'd win again and one you wouldn't. So when someone looks at the PODIS materials cost and says, well, that's expensive, show them this, because the materials aren't the cost, the labour is. And that's the conversation that could win you the job. So is this PODIS a cable? Well, technically yes. But the electricians winning the hotel contracts, the commercial refurbs, the multi-point installations, they're not speccing it like one. They're speccing it like what it actually is: a distribution system, a backbone, one supply, multiple tap-offs, a future-proof infrastructure that costs half as much to install and a fraction of the time to put in. The question at the start of this video was, what's the current carrying capacity of the cable? The real answer is, it depends where you are on it. And that's the point. That's what makes it different. The current diminishes along the run as each room takes its load. The cable is rarely at full rated current for any extended period, and when you apply real-world diversity to a hotel load profile, the supply cable, the switchgear, the whole upstream spec becomes a much more comfortable conversation. That's not a workaround, that's good electrical design. The system is not a cable, it just looks like one. And once you see it that way, you can't unsee it. If you want to dig into the PODIS system in more detail, installation process, process, connected technology, the car park application, then click the video on screen now.